Hey everybody. Now more than ever we're depending on devices with batteries to be able to communicate with each other and even to do school. For instance, I just bought myself a Apple Pencil so I can make these screencasts with you guys. So let's take a look at how you can calculate battery life based on the charge rating that the battery has in milliamp hours and the current. If you recall, power is equal to voltage times current, so P equals VI. P equals VI. So let's take a look at how you do the calculations for battery life. But before we get there, let's look at the units for battery life. Now, battery life is going to be in hours usually, though it could be in seconds if you use a different unit. The battery charge rating is in milliamp hours, and your current is in amps or milliamps. So if you're going to do math that uses current in that math, you have to convert it out of milliamps into amps. If not, it's usually okay to leave it as milliamps. So let's take a look at how you would do a calculation like this one. It says that you can use an Apple Pencil for 12 hours on a full charge. It operates at 3.82 volts from its battery, and its rating is 86 milliamp hours. What average current does it draw from its battery as it's being used? Let's see how many coulombs of charge it's taking on that battery every second that it's running. So first thing we start with is this equation that says life is equal to rating divided by current. I could make all sorts of jokes about the true meaning of life, but in this case, life is equal to rating divided by current. So it said that the life of this battery is 12 hours. The rating of the battery is 86 milliamp hours. Now we're trying to find the current. And in this one, we're just going to find it in milliamps first. So you cross multiply here. So 12 hours times I is equal to 86. It's a strange 6. Milliamp hours. So I is going to be 7.2 milliamps. Now, is that a lot of current? No, because that's in milliamps. So let's look at converting that to amps. So 1,000 milliamps for every 1 amp. It's going to be 0.0072 amps. That's not even enough to run like an LED light. That's a ridiculously small amount of current, which is good because it's a very small battery inside that Apple Pen. Now, as I'm grading your papers or doing these screencasts, let's see how much power that's using and compare it to a light bulb. So P equals VI. Says it operates at 3.82 volts. And the current is 0.0072 amps. So that's 0.028 watts. In comparison, a light bulb is usually, a modern light bulb is about 13 watts. An old school light bulb would have been something like 60 watts. So using very little power compared to those things. Okay. So, gave away the trick question. Which one's more powerful, a pencil or a sword? It's a trick question. There is no battery in a sword, unless we're talking about a lightsaber, in which case it is definitely the sword that is more powerful. Hey, just to compare, an iPad has an 8,827 milliamp battery, so that's 100 times as much charge as it can release through the circuit. That's stored as chemicals in the battery, so if you have that much more charge rating on the battery, you probably have about 100 times as much chemical, which makes sense because the iPad is actually mostly battery. It's just a big sheet of battery on the back of it. So battery on an Apple Pencil is obviously much lighter. And if you really want to know about how to charge your Apple Pencil best, you can look at that link on Google Classroom there. So let's run through one of these examples from your homework. So motorcycle batteries are significantly bigger than a pen battery. So let's look at how you would calculate this. P equals VI. So the power is 75 watts. Voltage, 12.6 volts. Question is, what's the current coming out of the battery? Well, we divide both sides by 12.6, and we get 6.0 volt amps divided by volts. Or in other words, amps. So 6 amps for your current. Now ask how many hours will pass before the battery is dead if they leave that on. So life is equal to rating divided by current. So life is equal to 5 amp hours divided by 6 amps. So it's going to be 0.83 hours until that motorcycle battery is dead. So that's why modern motorcycles, for the most part, and cars have a automatically turn off the headlights feature, because otherwise it takes less than an hour usually to drain the battery. Alrighty, folks. Let's do one more. The batteries in a remote control toy car are rated at 1.2 amp hours, which is actually pretty big. Battery's voltage output is 7.2 volts. If the car's motor draws 7.2 amps from the battery, how many minutes will it take to completely discharge the batteries? So that's life is equal to rating divided by current. So it's going to be 1.2 amp hours divided by 7.2 amps. And you're going to get 0.167 hours. But it didn't ask about hours, did it? It asked how many minutes. So we're going to have to calculate minutes. 1 hour, 60 minutes. So it's going to be, I have to calculate that actually. Ha! 10 minutes. That's why it seems like your car's batteries ran out so soon. How much power is the car's motor using? Power is equal to voltage times current. So 7.2 volts times 7.2 amps. It's going to be 52 watts of power. Your car is pulling about as much power as an old light bulb. Alrighty, folks. Hope these examples helped. Let me know when you have questions. Remember that Virtual Hive is at 1:30 this week, and it'll actually be at 8:30 in the morning next week, which is exciting. Talk to you folks soon. Bye.